Hello everyone, welcome to the channel. The videos which you see on your screen have been created with just a text prompt, and the model which has generated these videos is a brand new few hours old model called as Allegro, which is available on Hugging Face at the moment, and we are going to install it locally, and then we will also generate videos just from text prompt, and we will see if they are of this quality or not. Before I do that, let me give you a quick overview of this Allegro model, and then we will proceed to installation. Also, I would like to thank Mast Compute for sponsoring the VM and GPU for this video. If you're looking to rent GPUs on good prices, I will drop the link to their website in video's description. Plus, I'm also going to give you a coupon code of 50% discount on a range of GPUs, so do check them out, please. Okay, so let's have a quick look at this Allegro model, which has just been released. This model is a powerful text to video model that generates high quality videos up to 6 seconds at 15 frame per second, and also with 720 pixel resolution from just simple text input. This model is quite versatile, and it offers the user the flexibility to explore diverse creative ideas within the constraint of 6-second format. It is open source with Apache 2 license. That's correct. So that's very generous. And the whole model weights, whole code is available to the community, and I will also drop the link to it in video's description. As I said, you can generate a wide range of content from it, like close up of humans and animals to diverse dynamic scenes, as you can see on your screen. It also features a just 175 million parameter video V. V means variational autoencoder, and a 2.8 billion parameter video diffusion transformer model. It supports multiple precision from full floating point 32 to B float 16 and floating point 16, and also uses a 9.3 gig of GPU memory in PF16 mode with CPU offloading. The context length is around 80K, which is equal to 88 frames. And you can read further about this model on their Hugging Face card, which I will also give you in the video's description. So let me take you to my terminal where I am running Ubuntu 22.04, and I have this 1 GPU card, NVIDIA RTX A6000 with 48 GB of VRAM courtesy Mast Compute. Let me clear the screen. First up, let me create this virtual environment with Conda. I'm just calling it AI. Let's wait for it to get activated, and then I'm going to install a few of the prerequisites like torch vision and all that usual stuff, and that is going to take 3 to 4 minutes, so let's wait for it. And all the prerequisites are done. Let me clear the screen. Now the thing is that this model is not still part of diffusers, or even I don't believe it is supported by transformers. So what I'm going to do, I'm just going to download the weights of this model through Hugging Face CLI, and then we will do the inference with their own GitHub repo. So first up, we would need to log into Hugging Face. For that, the command is hugging face-cli login. This is going to ask the token for you. This token you can grab from huggingface.co. It's a free token. Just go to your profile and grab it from there, and then the read token should do, and just press Y, and you can see that we are now logged into Hugging Face. So that is good. Sorry, let me clear. And now next up, we need to download the model. So how do we download it? Let me first show you the command. So all you need to do is to run this Hugging Face.cli download, and then just create a new directory Allegro on your local system, and then run this command, and this is going to download this Allegro model on your local system. And you see the repo name is rhymes-ai Allegro, which I have grabbed from the Hugging Face page. From here, if you scroll up, you will see that. Okay, let me quickly show you. I think it should be here somewhere. So if you scroll down on that page, you will see that this is the Hugging Face page. So just open it in the uh, new link, and this is I have grabbed from Hugging Face, this repo name. Okay, so let me go back and run it. It is going to download the model from Hugging Face, and you can see that it has started downloading. So let's wait for it. It is going to take a bit of a time. And the whole model is downloaded. Let me show you its size. So if I do ls-ltr, you will see that at the very end we have this Allegro library, Allegro directory. So let's go into it. And then if I show you the size of it, it is 24 gig. So make sure that you have that much space on your system. Also, if I show you the content, you will see that there is a V directory, which is variational autoencoder. There is a transformer model there, and we have tokenizer, and then we have text encoder, the clip. So we need all of these, and I will describe what exactly they do once I run this. So let me clear the screen here. Now if you want to run it, all you need to do is to first maybe I'll just get out of this directory, and then I will just make maybe let me rename that model directory, because we also need to git clone the repo. So I will just call this Allegro to Allegro model, and now let's git clone the Allegro direct GitHub repo, because we need the script from there. So I have done it, so that is cool. And now if I do ls-ltr, these are the scripts which have been provided for inference by the Allegro itself. So let me clear the screen and show you how you can generate video from text. So from the root of the repo, you can run this script which says single inference, which is the script which does the inference, and this is a prompt or text input to generate videos at a seaside harbor with bright sunlight and sparkling seawater with many boats in the water. From an aerial view, the boats vary in size and color, some moving and some stationary. Fishing boats in the water suggest that this location might be a popular spot for docking fishing boats. And then this is where we want to save our video in maybe MP4 format, and then we are specifying our V or variation autoencoder. So variation autoencoder is the model which converts the images which are frame by frame from latent space to pixel space. Latent space is for the model to work upon, and pixel space is what we can see. And I have done various videos on it where I described the difference. So you can just search with latent space and you should be able to find it. And then we are specifying the actual transformer model, and then our text encoder, which converts our text input into the embedding or numerical representation which model understands. Also the tokenizer itself is there which converts it, and then we are specifying our CFG or guidance scale, which specifies the prompt adherence, that if the higher the value, it means that model will follow our prompt, lower the value, it will be more creative. And then these are the number of steps it is going to do, 100, in order to generate the video. And seed is just a random value to generate the noise, so that it is going to, the diffusion transformer is it is going to use that to create the image. So let me run it. It is running and generating the video, so let's wait for it to generate it. It is going to take a bit of a time, and then when it's finished, I'm going to show you the video. While that happens, let me also introduce you to the sponsors of video, who are AgentQL. AgentQL is a query language that turns any web page into a data source. With its Python SDK and live debugging tool, you can scrape and interact with web content. AgentQL works on any page. It is resilient, it is reusable, and it structures the output according to the shape of your query. And I will drop the link to it in video's description. Okay, let's see if our video is created. And now it is going to run those 100 steps on it. So let's wait, and then I will take you to the folder where the video is. And meanwhile it is doing those steps, let me also show you the GPU consumption. So you can see that out of my 48 GB of VRAM, it is consuming at the moment 43 GB of VRAM, which is quite huge, I would say. And it is running very slowly. At the moment it is showing me 53 minutes. That is fair bit of time for a second, 6 second of video. And it is, the time is fluctuating a lot. So let's wait for to see what is happening. I'm not going to wait for 1 hour, by the way. So I waited for 40 minutes for that prompt to complete, but it was still showing me more, further 40 minutes. So I couldn't wait that long. First I thought of canceling the video, editing it, and maybe going with this smaller prompt. But then I thought I'll be transparent, as is the spirit of our channel, and I will show you the actual thing on the ground happening. So what I have done now, I canceled that one because I already waited for 40 minutes. I have started this very small prompt saying a tiger running in forest. Same sort of stuff. The only thing which I have changed is that I have changed the steps to 30 from 100. I know that this is going to reduce the quality, but we just want to see what sort of video it generates, and whatever video generated is going to give us an idea how much would it improve with the 100 steps. But you see that still with the 30 steps, it is in total has already, it is showing me in total 20 minutes, and almost 8 minutes have passed, and 12 minutes are remaining. So let's wait for 12 to 15 minutes to see what it creates. So it's almost there now at the last leg. Hopefully it should be done very soon. So regardless of the fact, I think the model may be good, as it is said on their model card that it is quite advanced. But I think the way it is taking so much time just to generate 6 second video is a concern, I would say. And if you have been following my channel, you know that we have covered a lot of text to video models, including cog video and various others, and they don't take that much time, maybe 20 seconds, 1 minute, but this one is too much. You see that it already has taken more than 21 minutes, and still it is, I guess, saving it on my test. So let's wait to see what it generates. And there you go, it has created the video and saved it. Let's check it out, and I will check it with you. I'm just going to double click on this test video. Remember, it was just a tiger running in forest. The video quality is very, very good, I must say. Let me play it again. So you see, the prompt was just a tiger running in forest. There is a forest, and the soil is quite good. It is going in the reverse, but that is fine. I mean, we could of course check it, fix our prompt there. The tail is bit malformed, I would say, but I think again, if we properly run it in something like Comfy UI, we could give negative prompts and then fix it. But most of, above all, I think if we just look at the video aspect of this model, which is quite good, the tiger is quite well formed, no problems there. There is a forest, there is a I would say fog in the forest, so it looks good. So the model is slow, but the quality is quite good. And by the way, this is the same company which created the Aria model, which I have already have covered on the channel. So that's it, guys. I hope that you enjoyed it. Let me know what do you think. It has taken me around 3 hours to just create this video, because I had to go through all of the code which they have performed. Hopefully they will release some proper easier way to get it installed, either through transformer or through Comfy UI. But even if you want to play it now uh, in this way, feel free to check it out. And then if you want to create a longer video, then make sure you give it a very long prompt, and then with proper all the details, and then run it for 100 steps, and then you might not see these malformation, and you might see better result. But remember, with this 30 steps it has created is very, very good quality video. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network, as it helps a lot. Thank you for watching.